Hello and welcome to Section 8 for Volume and Surface Area. We're going to talk about volume and surface area for rectangular solids, cylinders, cones, and spheres, as well as polyhedral shapes, prisms, and pyramids. And we'll talk about solving problems that have cubic units. Volume is basically the measure of a three-dimensional figure and what it can hold, like what you could put inside it. Surface area is the sum of the areas of the sides or surfaces of the figures, or what's on the outside. When we start talking about three-dimensional solid figures, we're talking about what's called solid geometry. Those space figures fit inside a branch of geometry where we are exploring things like volume and surface area. Please note when you're talking about volume, the dimensions are always cubic units, like cubic feet or cubic meters. When you're talking about surface area, because it's two-dimensional, it would always be square units, like square feet, square meters, square centimeters. Once again, you will have a formula page, but here are some formulas that you're going to be using. If you have a rectangular solid, like an Amazon.com box, the volume is length times width times height. If you have a cube, it's simply side times side times side. If you have a cylinder, like a soup can, the volume is pi r squared, which is actually the base of the bottom, that's the area of a circle, times the height, so pi r squared h. If you have a cone, it's 1/3 pi r squared h. And a sphere, kind of like a playground ball, is 4/3 pi r cubed. Surface area formulas are here as well. If you took apart your Amazon.com box, you would notice that there was a top and a bottom that were the same, there were two sides that were the same, and the ends were the same. Hence, you have two length times width pieces, two width times height pieces, and two length times height pieces. For a cube, one side is simply a square, so the area is s times s, and you have 6 of them. So you have 6s squared. For a cylinder, you have the bottom, which is your pi r squared, but you have 2 of them, the top and the bottom, so 2 pi r squared, and then you have the side, which is 2 pi r h. If you actually sliced down the side of the can and laid it open, it would look like a rectangle, and the length around, the distance around a circle is 2 pi r times the height, and so that's where this part comes from, 2 pi r h plus 2 pi r squared. The cone formula is a little more involved. We're not going to really see that one too much, but that one's here as well. And a sphere is 4 pi r squared. Again, be careful with things like the cones or the sphere. If you're given the diameter all the way across the circle, you're going to need to make sure to take half of it to get the radius. So here's a nice succinct formula page. And here's an example. We're going to find the volume and surface area. So this is your Amazon.com box. So the volume is length times width times height. 10 times 5 times 2, or 100. Remember that the units are cube units because this is three-dimensional, so 100 feet cubed. The surface area, if we peel it apart, is 2 length times width plus 2 width times height plus 2 length times height. So it's 2 times 10 times 2, 2 2x5s, and 2 10x5s. Or again, 160, but remember it's square feet. Here's a cylinder. Now you can use the pi button on your calculator, or in MyLab Math, it may tell you to use 3.14. Pay attention to the round off rules. If it's asking you to round to the nearest hundredths, that's 2 decimal places, that kind of thing. Volume is pi r squared h, 63 pi, or approximately 197.92, and again, cubic inches. Surface area, 188.5 square inches, For a cone, again, walking through 2 samples, make sure when you're dealing with this that you actually do have the radius and not the diameter. And again, watch your computations, round to the appropriate number of decimal places. For a sphere, once again, make sure you're using the radius and you round to the appropriate number of decimal places. If we talk again about a polyhedron, or polyhedra, plural, that's a closed surface formed by putting polygonal regions together, things like cubes and tetrahedra and octahedra, things like that. So we're going to look at what's called Euler's polyhedron formula. The number of vertices or corners minus the number of edges plus the number of faces, aka flat sides, equals 2. So if you look at a prism, for example, that was where you'd have congruent polygons for your bases and the sides are all parallelograms. Looks something like these. You could ostensibly count the number of vertices, 1, 2, 3, 4, 5, 6. You have 1, 2, 3, and then this side, the base here, 4 sides or faces. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. When we use the word prism in the book, we're referring to a right prism, meaning that if you sat this down on a tabletop, it would not wobble. It's perpendicular. The volume of a prism is the area of the base times the height. And so you can do something like find the volume of a hexagonal prism fish tank. So they're showing you here how if you divide that base, it's 2 trapezoids. You find the area, you double it, so it's 192, and then you're going to multiply it by the height, which is 24 inches. And so we had the value in cubic inches. Now we want to know how much water that can hold. So we find out that it's just about 20 gallons. A pyramid is going to be a polyhedron with one base, but it comes to a point. All but one face intersect at a common point. The volume of a pyramid is 1/3 the area of the base, capital B, times the height. So if the base is a square, like this one, then the area of the base is 5 times 5, and the height is 6. So it would be 1/3 times 25 times 6, or 50 cubic meters.